Signal Sciences is the industry's first web protection platform that works in any cloud, any container, any platform as a service, and any modern application architecture. The Signal Sciences web protection platform can be deployed in next-generation WAF, RASP, or reverse proxy modes, giving customers ultimate flexibility and coverage. Protect your web applications with Signal Sciences web protection platform. Signal Sciences, protecting applications, connecting teams. For more information, check them out at signalsciences.com/PSW. Onapsis is the leading provider of solutions to protect ERP systems from cyber attacks. Customers can secure their SAP and Oracle business-critical platforms from espionage, sabotage, and financial fraud risks. Visit them on the web at onapsis.com. The SANS Institute, the most trusted source for computer security certification training and research. Visit sans.org to explore their full curriculum and latest training offerings. Welcome back, everyone, to Paul's Security Weekly. I want to remind everyone to check out Endgame's webcast, which is happening next Tuesday, September 19th, from 4 to 5 p.m. Eastern Time. Endpoints are, of course, the breeding ground for malware and malicious payloads. Here, John Strand and myself talk about some phishing technologies and information about how to protect against phishing. Then hear Mike Nichols' take on Endgame's, I'm sorry, not phishing. Why do I keep getting these mixed up? All right, here's the deal. Take two. We're doing one webcast on endpoints. How to protect yourself on the endpoint and evaluate endpoint protection software. John Strand and I will give our take on endpoints, how you evaluate specifically considerations for detection rates, deployment capability, scope, maintenance, and resilience, or a mix of all. Then we're going to, and so you can go to securityweekly.com/endgame, get information about that. Okay? So make sure you go there, securityweekly.com/endgame. Here, John, myself, and Mike Nichols talk about all things endpoint detection and response. Do that. Then we're going to do I don't know when, sometime after that with Greg Foss from Logarithm. So you can go to securityweekly.com/logarithm September 26th when we get back from DerbyCon and hear about automating detection and response to phishing attacks. So you get John and I's take on phishing attacks, and then Greg Foss's great research on how to detect and prevent phishing attacks using some of Logarithm's technology. These are two webcasts you don't want to miss. securityweekly.com/endgame and securityweekly.com/logarithm. Make sure you do that. Go there, and you will have fun. I promise. How about that? Now,
hey,
Michael,
since you mentioned Greg Foss, I need to give a shout out to him just because I was hanging out with him earlier this week.
Yeah, you guys were like having cigars and stuff.
Yeah, we were having cigars. And a shout out, we were just sitting in this cigar shop in the Pentagon City, and there was a guy there chatting with us, and he said he was in IT and he was interested in security, and they finally introduced me, and he's like, Jeff, man, that name sounds familiar. I said, Security Weekly. He's like, that's it.
Yeah.
I know you. But he's a podcast listener, so he had no idea what I looked like.
Oh, that's really cool.
So shout out to John that I met at the cigar shop in Pentagon City earlier this week, and Greg.
Awesome. So Michael Assante has joined us. Michael, welcome to the program. How's it going?
It's good. It's good. I got to tell you, I've got serious headset envy there, Paul.
Oh, yes. Yeah, these are, we can send you the model number. They're, you can afford it at your salary, Michael. I'm telling you. You'll be living the dream. Yeah.
I'm rolling.
There you go.
I can't even afford a good internet connection. What are you talking about?
Well, no, there's not a good internet connection available to you, but I bet you get great other benefits living in Wyoming, like beef and stuff, right?
Beef, deer, elk, you name it.
Bison. I'm jealous.
We're pulling off this webcast on a 28.8 modem. It's pretty cool.
It's pretty awesome.
It looks like it, doesn't it?
Michael, for our listeners, why don't you tell us a little bit about your background and what you do?
Sure. Yeah. I've been working in the area of ICS security for the last 20 years, focused on command and control systems, automation, critical infrastructure. Did a lot of work in the energy sector, and just the last 5-6 years put a strong focus on workforce development, as you know, Paul. So everything from hosting content events like the ICS Summit to helping with the SANS ICS curriculum and getting good content and training out there to people to learn how to protect these systems.
It's fantastic. Michael, what's the topic today for your technical segment?
Well, you know what? I wanted to be really current. There's a current access campaign going on out there called Dragonfly 2.0 by Symantec. And a little bit of confusion of what that means. There's been everything from the discussion of people are ready to shut their lights off in the grid to, how do I make sense of this? What is this? What does that mean? And I figured we might kind of step back and understand control systems, present a couple of models for how those attacks work, and try to understand what Symantec. Yeah.
Michael, what's Dragonfly 2.0? All
right. So Symantec calls what looks to be an access campaign and exfiltration campaign so far, Dragon 2.0. That's because they've had a Dragon 1.0. Dragon 1.0 also goes by the name of Havix, but was an access campaign in 2013 circa time frame, 2014, and it was very much focused on gaining access to control system targets. Some of the techniques and delivery techniques they used, we can go through what kind of made it unique. And, back in 2013, we were worried about that. And now fast forward to 2017, and there's another round of campaigns underway. It appears they've been very successful. Symantec suggesting they're pulling a lot of information out of these targets, and the information includes HMI screen scrapes, for example. We'll talk about what that means. And so they're dubbing this campaign 2.0.
I gotcha. Is Symantec, being the researchers that found Stuxnet worked for Symantec, do they have a real focus on ICS and industrial control systems in terms of discovering this type of malware?
You know what? They've made some good decisions relative to putting resources and diving deep, as you know, Liam, as it related to Stuxnet, and then Dragonfly 1.0. They really spent a lot of time, were very well instrumented with their customers to kind of get good insight. So I would say they're not necessarily a heavy focus on control systems, but they've got folks there that are smart and capable, and they understand malware. So in this case, they've used that to be able to stitch together what they believe is occurring. They have openly admitted that they're not control system experts, so they're trying to help make sense of what's going on out there. And I figured tonight we could kind of walk through that a little bit and try to bring some clarity to it.
Michael, one more background question. Have you, over your years in working in ICS, have you seen an uptick in an increasing trend upwards towards malware that's specifically targeting ICS and critical infrastructure?
Well, you know what? We've seen kind of two things. On the malware front, when you just think about malware, the answer is yes, but we're talking small numbers. So you could argue Stuxnet was the first publicly available malware that was highly sophisticated, highly surgical and targeted, had a very strong control system aspect to it in multiple dimensions. And now something that's been called crash override by Rob M. Lee and Dragos and ESET called it InDestroyer is another malware package that looks modular as a framework, has plugins that clearly are control system capable plugins, everything from wipers designed to wipe specific control system files to actual comm modules that might allow you to inject traffic, for example, and manipulate or operate a control system and the system it's tied to. So the answer is those are two examples of malware that were clearly customized. Now, Havix itself, Dragonfly 1.0, had an OPC module, which is a type of control system solution that allows you to communicate either horizontally or vertically in a control system. And they have the ability to pull information out of that system and potentially interact with the system. So, I'd say there's been three flavors of malware. There have been other proof of concept code we've seen out there that have had control system capability in terms of changing set points. We've seen lots of demonstrations or scripts, if you will, out there that would perform a function against a control system. But packaged up, operationalized malware, there's really only been three examples of that in the real world.
Gotcha. Thank you for that. That's awesome.
Sure. Absolutely. So let's talk a little bit about actually let me maybe start by presenting a bit of a model, if I could share a screen, if you can actually see it across this 14.4 modem. I think I'm downgrading.
It went you downgraded. It's going to be 9600 as we go along.
I'm going down to control system speeds. That's the deal here, right? All right. So
he's going down to 300 board before we know it.
Not yet.
Right.
I still see you.
Oh, good. Well, there you go.
Oh, yeah. I mean, that's a bonus. I see you, Michael.
That's nice to see me. And
It
I
looks
see
like
you,
a
Paul.
fish. It looks like a fish in the back. Are you a fisherman?
I am. Actually, I'm just a lucky guy. I did catch a nice sized fish somewhere, so I got a big sticker, so that was helpful.
There you go.
My wife is actually the fisher woman of the family. So
Is it fly fishing out there?
lots of fly fishing. This is
Awesome.
definitely a fly fishing capital of the North America, kind of scape. It's really pretty.
Interesting. That's a very relaxing form of fishing. I've always wanted to try it. I think it's on my bucket list, definitely, to do a fly fishing trip. I have 3 sons, so hopefully that opportunity presents itself in the future.
Paul, come on out. I got a place.
I can make that happen, Paul.
Yes.
If you're willing to go to upstate New York.
There are lots of places to do it. It's
There's
awesome.
nice fly fishing there too. Yeah. Well, let me do this. Instead of showing screens, let me just maybe talk to you through a bit of a model.
Sure.
We're all familiar of a traditional kill chain, right? Lockheed Martin concept. And this is just a model to break down an intrusion and describe the various steps it takes for the intrusion, for an intrusion to occur, for the adversary to conduct activity or action on a host, maybe grab credentials, be able to move throughout the system, perform additional discovery, and then what types of actions they call it on target, right? What are they doing? And in the traditional model, you've got this multi-stage kill chain. And, when you think about control systems, we designed kind of a stage 1, stage 2 model. Our idea was that not only will many attacks have aspects of a stage 1 where an attacker is trying to go from their environment or network, let's say the internet, into a corporate environment, or directly into a control system. So they might conduct reconnaissance, they might weaponize some capability, they try to deliver that, they exploit, let's say, a host or an operating system, install their own malware, establish command and control or some type of interactive session with the target, and then begin to act. And that's the traditional model that we've kind of defined some defenses around and how we deconstruct incidents, and we like to talk about how things occur. In that model, the actions an adversary might take would be, further discovery, further movement. They might install additional tools in order to conduct, other actions, capture information, exfiltrate information, and then take actions like cleaning up their tracks or quite honestly, sometimes even defending their holdover assets if they hijack resources. That's a traditional model. We've created a second stage. We think with a control system, not only do you have to typically intrude upon and gain access to a network, but you have to collect information, credentials, and then usually cross a gap. We call it, gap jumping, going typically normal control system has some form of segmentation between a less trusted corporate environment and the control system itself. Now, some people take this way too far and talk about air gaps, like we're completely air gapped. I've never really seen a sustained air gap. I always think of everything temporally. So in a moment of time, you can maybe suggest that you're physically segmented, but control systems need files to move, just like any type of a larger system that actually does something. You need to interact with it. And so the truth of the matter is...
So, Michael, the HMIs and the PLCs are typically the ones that are air-gapped together, right? The HMI being the typically Windows software that I interact with that allows a human to interact with the devices that are attached to physical infrastructure that open and close valves and monitor temperature and all those kinds of fun things, right? Is the malware targeting the HMI? I know we saw Stuxnet specifically targeting the PLCs, but some of the malware must target the HMIs because that's what allows them to control the PLCs, and typically that entire infrastructure is air-gapped, correct?
Yeah, let's talk about that. Well, first of all, I don't believe typically the whole infrastructure is not air-gapped. Most infrastructure are absolutely networked. They're just very controlled in terms of how they're networked, right? The type of connections across the firewall, for example, are going to allow you to push data out to databases. It's going to allow you to take certain communications into the environment. So there's some level of segmentation.
Now Michael, that segmentation, is that typically a specialized firewall vendor? I know I love Lior and Waterfall Security, and I know there's other vendors in the space, but is that typically a specialized firewall vendor?
So broad range. I'll tell you, I've seen everything from normal general purpose firewalls with terrible rule sets, to application firewalls where the control system communications, both ports and services, and the required communications were well understood. So they were tightened all the way down to have decent, control of the communications that were leaving the control system environment, to specialized devices like the Waterfalls data diode solution or unidirectional security gateway, in which you've really understood what information has to leave. You've worked on being able to convert that using the data diode or the unidirectional security gateway in order to really achieve a one-way physical layer communication. And in some cases, they even have solutions called flips, where when information has to leave, great. Sometimes you need to have maintenance or remote maintenance or services occur, and so it flipped back the other way to allow that. These single direction connections at any given time. So you've got a spectrum, Paul, from really poorly architected segmentation using general purpose firewalls, and typically, in many cases, we find rule sets that aren't as restrictive as they should be, to application-based firewalls, to unidirectional security gateways as that enforcement device. Yeah. And you're absolutely right. I mean, a control system itself is clearly just a technology that enables you to take information physically about a process, usually through instruments, pull that back through a controller typically, push that information to databases or that information to applications that might sit like an alarm server or an application being a human-machine interface. This is where a control room operator is going to sit. They're going to monitor a process by a pre-designed graphical display. It's going to display that instrument readings, temperature, pressure, those types of things. It's going to provide state data. A valve is open, a valve is closed, and it's going to allow an operator to manage a process using that technology. Now, the controller itself is either there's two types of control. There's supervisory control, where the control room operator might want to open or close a valve, so they're going to send a command. Or the controller itself has logic in it. And that logic is designed to sense certain instrument conditions, take those readings back, perform math, and have what we sometimes call closed loop control, those types of things, where the controller says, for me to regulate the system, we're going to change the position of a valve. We're going to increase the heating element, or the temperature by turning heaters on, and we're going to turn those off. And all that logic might be sitting in that controller. Now, when the controller communicates back to the process, you're typically interfacing with things we call actuators. So those are things that will actuate something in the physical world. That's typically a system. Some systems have more applications associated with them, so they have multiple servers. Other applications are as small as that HMI we talked about, a controller, several instruments, several actuators.
Michael, I have to ask, because in a previous life, I worked for an industrial control system security company, Digital Bond, in Dale.
Yeah.
The guy, awesome, fantastic group of folks. And the only reason I actually left there was because I had an opportunity at Tenable to go work for them. And I was actually working with some Tenable technologies, and I was working with Wonderware. Is Wonderware still an HMI? They provide HMIs, correct?
It is. Wonderware is still a software package out there. It's since been purchased by Schneider Electric.
Oh, okay.
But the Wonderware application and their GUI interfaces are kind of they really made a mark on the control system automation space, and they're still around. Absolutely. I used to work at a large electric utility, and we had gas operations as well, and we had Wonderware deployed in the system, and
now, to plug a vendor in the ICS space, they were actually working with Digital Bond, and by extension myself at the time, to harden their system for security purposes at that time. So to me, they always kind of stand out as a vendor that was very forward-thinking several years ago in being able to do some hardening, which is why I wanted to mention them on the show. And I knew you would know them, having worked in the space for 20 years. So that's really cool.
I've had a Wonderware incident or two where I actually had I might have knocked over a couple of those systems by accident in my former life, but yeah, it happens.
It happens.
It happens. So, but it's interesting. What you talked about is really important. That idea of segmentation and the idea that you've got another network that's really a very engineered environment, right? And that in theory, because it's engineered, we should be able to control the types of communications that occur inside that environment. And so it's why we felt that there's not only a stage one that what really did a good job of describing a typical enterprise type cyber incident that's highly targeted. You could talk about these steps. But we believe that a control system allowed us to build a stage two to that kill chain. And in stage two, the idea is that the actor or adversary would have to get enough information or credentials to be able to jump the gap, get from the stage 1 environment into the control system environment. After jumping the gap, typically the adversary, if you wanted to conduct an attack that would have an effect on the physical process in a highly predictable manner, I mean, you could go in there and cause chaos, as you can imagine. For example, with the old Wonderware solutions, if you want to there's lots of ways you could cause denial service conditions, or you could cause the network cards to stop working, for example. That would be very sophisticated. You could potentially do that by just, quite honestly, lighting off a highly noisy scans, right? Could actually knock systems over back then. But if you wanted a highly predictable outcome in the process, it kind of requires that you conduct a stage 2 to that kill chain. And the way we describe those steps is we believe that there's a con-op or attack development, the idea of how would I attack this system? What do I need to know about the system? Where do I need to be on the system? What could I do in terms of changing set points on controllers, or actually controlling, to your point, controlling the process through the HMI itself? Can I do that?
Right.
Is there a safety system within the control system that I have to deal with? You have to kind of do a lot of discovery, try to understand the system and the process that you're dealing with. And then I really believe that you have to kind of test and validate all these assumptions. If I want to cause an overpressure condition, I might be able to do that by jacking the temperature up. But there's going to be, can I jack the temperature up for a long enough time to achieve the overpressure condition that I want to achieve?
So does the HMI, Michael, have protections against that to prevent that from happening? And maybe my malware wants to communicate with the controller or PLC directly?
Right. It can. So a couple things. The type of connection between the HMI and the controller could have constraints that might not allow you to perform certain functions.
Right.
In the application itself, for example, if I'm just driving the HMI, like I'm literally going to change values.
Yeah.
Some applications might actually have, high points and low points where you can't exceed something. So you could try to put it in, it's not going to work. Those are the type of things that the attacker is going to have to try to understand. And honestly, we say in this one step, we believe there's a validation step, meaning I've got a theory. Can I actually control or change that set point? And can I do it long enough? Can I overcome the dwell time necessary in a process to achieve my outcome? And so they kind of call that a validation step. And then once you kind of do all that, you can position, deliver your attack capability, your malware to the right place. You can kick it off so it's going to go perform an attack.
But there's multiple points, Michael, in that the kill chain, so to speak, where the HMI might have protections, the PLC might have protections. There could be other physical protections.
Absolutely.
And for example, we've all watched Mr. Robot or other TV. Maybe it wasn't Mr. Robot. It was another TV show. It was a horrible one that they caused the printers to catch fire, right? And it's not like a software thing. Like if physically inside of the hardware, that's impossible. That's right. And I'm sure those conditions also obviously exist in industrial control systems.
That's right. Honestly, there's actually multiple places for those types of things to occur. There's the actual, the application itself is an area that might have some limits, right? The good news, bad news. Typically, if I'm living on the host, I have access to the application, and I can get administrative access to the application. Mm-hmm. Applications are made to be flexible, so I myself could probably change the programming, right? I can change the constraints within the application.
Yeah.
Also, I could actually get on that box where the HMI sits. I don't need the application. I can actually just simulate communications for the application. So I might be able to bypass any controls that the applications had on what I can do and just send a command to the controller, which might tell the controller to do something. Mm-hmm. The next step is if I move down to the controller itself, then the registry or whatever's receiving inputs, I can go in there and I can actually change maybe logic constraints where the logic said only allow it to ramp up so far or so fast. Mm-hmm. And I might go in there and actually change logic or change set points. And in that case, I can actually overcome what the engineers would say. We'd never operate the process this way, so let's go ahead and build some safeguards into it, right, in case somebody just made a mistake.
So that's interesting, Michael. So in the case of Stuxnet, there was no protections in those controllers to be able to prevent against those basically telling the controllers to make the equipment operate outside of those parameters.
Well, in cases like Stuxnet, what you have is you have the ability as the attacker to kind of, if you will, just think about it in a very simple model as reprogramming the controller.
Mm-hmm.
You can actually build the type of functions the controller is going to perform. There's a physical wiring that you can't change to, right? Usually, remotely, you can't change the physical wiring. But exactly what type of output and signal is being sent from the controller, you can modify the logic of the controller. You could actually lie to the controller in terms of inputs, so you can actually use the logic is in place, but you're telling
is that
it
because
that
you can change the code on the controller, right? Like when we talk about embedded systems, much as we do in the show, like there's an operating system layer and there's applications that run on top of it. But when we're talking about PLCs, like largely it's code running right on the chip, and if you can change that, it doesn't matter if there's protections. Like you're changing that actual code anyhow.
Actually, and it's even more flexible than that, Paul. I mean, you might change the firmware, which is holding the logic.
Mm-hmm.
You might change system software layered on top of that. Or you might honestly just go to the backplane and lie to the controller, right? So at the backplane, you can say, hey, your input tells you your temperature is at 90 degrees when it's really at 200 degrees.
And that's what Stuxnet was doing, right? It was lying to the protection mechanism. Yeah, okay.
Correct. And then in this case, you've got equipment, in this case, the actuator, or it might be like a variable frequency drive, right?
Mm-hmm.
And that drive, how can you control that drive is based on the engineering and the physics, right, of that drive and what it can do and how you control it, right? So you can even go beyond the controller in some cases and start changing the parameters, configurations, or even the capabilities of the firmware sitting on things like those drives or motor control units, for example.
Right.
So, what's interesting about control systems is if you take an engineering approach to that process, you might choose to attack in different places to achieve a certain outcome, right?
Have they built in, Michael, have they built in more physical hardware protections, like based on some of the malware such as Stuxnet and others that do this? Are they built in more physical protections because of that?
So you know what? Traditionally, we had, and some processes have this. They have an integrated safety system, and they have a control system that's controlling a process and monitoring a process. Then they have a separate system. It used to be more separate in the old days. It used to be physically separated. Had its own network to communicate to instruments and actuators. And this system would sit there. It would monitor very specific, points in the system, and let's say temperatures or pressure settings. And it would be told a whole different set of logic, saying, if you ever see this, that's a dangerous condition, and the safety controller would perform a control function of shutting down its own valve, for example, that would stop the process. It would shut it down safely. So you do have systems like that. But in today's world, we've gravitated towards more converged systems. So you might have a specific safety system, but shares the same network, or it's even sharing the same instruments inputs. Or in the next wave of convergence we're talking about performing both control and safety on the same platform. So one controller to do both, and the idea the logic is different. And as you know, for an attacker, that's great. Put everything in one place. If I got access to that device, I could get an escalated privilege on the device. I most likely can affect both the safety function and the control function. So in that case of safety systems, we're seeing that as a safeguard against malicious attack becoming less and less of a mitigation, right, or a consequence reduction in today's world. And to your point, this idea, if I can attack a system this way, like a Stuxnet, what do I do? Well, certainly engineers have options. So engineers could go in there and physically put actuators or control of physical equipment in place that would disrupt your ability through cyber means to cause a problem. I've written a few papers about a case for simplicity. So in cases where it really matters, instead of having a highly flexible programmable controller, to have something that's far more constrained, or even to have what we would call a fallback system. That's, some people like to use the words analog. It doesn't have to be analog. It could be burnt in glass. It could be, that could be burnt in silicon. It's just not programmable, right?
I gotcha.
So things like safety systems on nuclear reactors. The idea is in the future, we have digital safety systems. Those are flexible general purpose controllers. They might meet nuclear standards, but they're still programmable. And maybe what we need is fallback systems that are not as programmable, right? In case all those security layers break down and an adversary can get access to that safety system, then you've got this last final, if you will, something that the remote attacker cannot manipulate.
I like that a lot, though, and I think that extends even beyond industrial control systems, right? I think about the locks in my home,
Sure.
which my home is all electronic locks, right? Because I'm a nerd and I like to connect those things. One of the physical safeguard, actually, that's implemented in software, you could bypass it, right, is that your Alexa system isn't connected to your locks. Like, by default, they're like, no. Amazon's like, no, you can't use your voice to control the locks in your house, right? But there's still radio communications that can do that. If you had a physical button that, like, when you lock yourself in your house, you can just push it and say, no, I've effectively disabled all of the radio communications because I'm inside the house. I can do that. Essentially, what we're saying is the same thing for industrial control systems. Like, there are physical safeguards that can protect against that. I think that's really significant. I like your idea for your paper, Michael. That's good. That's good.
There you go. So so what's interesting about that? It leaves a lot of confusion because people think, okay, if I get access to a control system environment, so let's say I have the ability to deliver something in there, well then, geez, all hell's going to break loose. And the truth is, to attack a control system in a way that you're going to cause again, my definition is a predictable outcome. Under that definition, it really requires an understanding of the process, maybe the engineering that went into it, how the control system's configured, and then what can I do or what do I have to do so I can do what I need to do to have that effect. And so, hence, attacking a control system cause the lights to go out. That might be, moderately difficult because if I just hijack the system, I use it the way it's intended. Well, we have the ability to open up circuit breakers, right? We can turn the lights off. The system operator has to be able to do that from the control room sometimes.
Right.
So I just use the features of the control system. For Stuxnet, the idea was I'm going to operate the system in a way it's capable of, but maybe not designed to, because I'm going to take it to a dangerous place and break something. In those cases, it takes a lot more engineering by the attacker to understand what set points do I change, how do I change them physically, the model on the machine. How do I break the machine? Do I make the machine go really fast? Do I then all of a sudden abruptly stop the machine? What is the physics effect? And we've used this terminology, the physics payload. What's the physics payload that you need to damage maybe equipment under control or damage a process in a way where you rupture a pipe? Or you cause a vessel to have a vacuum, right, and actually collapse on itself. That physics understanding could be significant, right? And so this idea that a stage 2 is a very powerful idea because one thing, I believe control systems are very defendable. And if you think that you're trying to defend against attackers performing these types of attacks, turning lights off or causing physical damage within a process, then you can start thinking about what an adversary would need to do to begin to understand and piece that stuff together. Now, that's important because the one caveat to all this stuff about, getting across the gap, operating in the control system and learning those things is, unfortunately, in any real world situation, we don't live in the control system environment by ourselves as engineers. We have a corporate desktop, we have servers, we have engineering files, we have engineering libraries. We have statements of work that go to contractors. So a lot of this information an attacker might need could live in that corporate environment, right? And those credentials could live in the corporate environment. And program files, for example, for the control system might find their way into the corporate environment and go back into the control system. So that gives an adversary an opportunity without tipping their hand to learn a whole lot by intruding upon a company's network before they go to the next step into getting into the control system and doing something.
Michael, I could talk all night. This is fascinating. It's really awesome.
Go
ahead, Jeff. You had a question?
Quick question?
One question. Go ahead.
And it's totally
Sure.
unrelated, but do you have the world's largest Keurig cup collection behind you, or what is that?
Oh yeah, that's hazelnut over here, right? And that's those are coins. Those are coins. I'm a
Challenge
former
coins.
military officer. Yeah,
Okay.
so those are military challenge coins good folks that I work with out there in the field, hand each other our coins, that kind of thing. We even have SANS coins, as you know, right, Paul?
That's awesome. Yeah. Oh, yeah. I've got quite a few.
Testing coins. We've got the control system coins, right? And we're so geeky that our coins they're like little cogs, right? So we've got cogs for our coins. So there you go.
Nice.
Well, being a geek can only get you so far, right, Ted?
That's right. So, Michael, when is some ICS SANS curriculum happening? It's usually in the spring, right, in Orlando?
Yeah, we usually have our big annual summit in the March timeframe, and we're going to do that again in Orlando. And we have a good time. We bring in folks from heck, we brought on Paul once, right? Hey, we had a good time, Paul.
I did. I was there was I there twice? Yeah. I was there a couple of years. Yeah. I taught a class once. I covered some stuff once. It's a great time. If you're interested in industrial control system security, fantastic conference, very well run. Michael, you've been on panels before on Security Weekly we've done there. It's a great time. So
it's fun. Yeah, we like to get our hands dirty. We like to do demonstrations. We like to provide ICS targets for people to play on. We do an ICS Net Wars now. We also talk about what works in terms of how to defend these systems, what types of technologies are affecting them, where things going. It's kind of meant to be the one-stop shop to understand how to defend and protect these systems.
Awesome. I encourage everyone who's in the ICS industry or interested in that to attend. The courses are great. Actually, one year I sat in a number of different courses, and I learned a lot. It's fantastic, Michael. We thank you for everything that you do. Encourage everyone to attend, and thank you very much for appearing on Paul's Security Weekly. All
right, Paul. Thanks for having me. Looking forward to seeing you again.
Absolutely. With that, we're going to take a short break, come back, talk about the security news for this week, or we might talk about Equifax. Not sure yet.